Welcome to our discussion on the uses and abuses of percentages. Okay, so here are some of the more common usage of percentages. We can think of percentages as a fraction, right? And that's really all a percent is. If you look at the word percent, it means per 100, which just means divided by 100. So 2.6% is literally just 2.6 over 100 of something, right? So that's why it makes it very easy to go from percentages to decimals, because 2.6 divided by 100 is 0.026 as a decimal. And so if we wanted to figure out how many employees actually lost their job when they tell us that 2.6% of the 13,000, and of is always multiplication, right? So you just take 13,000 times 0.026, there's your 2.6%, and that gives you 338 total employees lost their jobs. If the Citigroup stock fell 15%, right, we can use percentages to describe the change. Falling 15% means it's gone down 15% to $44.25. And again, we could calculate that if we wanted to. We could figure out what it was, before it went down 15%. And then we can also use percentages for comparison, right? So we can talk about it as just an amount, 2.6% of the newspaper, workforce lost their job. A change, it went down by 15% or up by 50%, right? Up and down. And then comparison, saying that something is 125% more than something, or sometimes you could say 125% of something. In this case, they say the advanced battery lasts 125% longer than the standard one, but costs 200% more. So you see how they're comparing those two things. They're all basically the same thing, just slightly different wording. And all that really means is the math involved is a little different. Okay, so here's a simple example. 64% of 1,069 people surveyed said they think the president is doing a good job. We can figure out how many people that is by just taking 64% of 1,069, which means we multiply 1,069 times 0.64, and we get 684.16, which of course we round to 684 because you can't have 0.16 of a person. And you might ask yourself, well, how does that work? And how come we didn't get a whole number? Well, if we go in the other direction, and we actually just take 684 people, right? Divide that by 1,069. So that's going to give us what percentage of the people, right? Because we have 684 out of 1,069, and that's going to give us a decimal, which we can then turn into a percentage. And that decimal, 684 over 1069, equals 0.63985 if we take it out to 5 decimal places. And if we convert that to a percentage, that is 63.985%, which of course rounds to 64%. So that's what's happening there. They just rounded it. All right. Absolute and relative change. Again, other uses of percentages. We're going to see a couple different versions of the same thing. So here we're going to talk about change, and later we're going to talk about another absolute and relative blank, and you'll see that they're pretty much the same thing. All right, so in this case, when we use the word change, it's just describing an actual increase or decrease. So your absolute change just means how much did something go from one value to the next. And you always have to know in which direction, right? Did it go up? Did it go down? So you have a starting value and a finishing value, right? So it's the new value where it finished at, right? Minus the reference value. So it's kind of like where it finishes minus where it started. So it's always that And so sometimes it can be negative and sometimes it can be positive. So for instance, if the price of your house during the big housing crisis went from 200,000 down to 150,000, right? Well, it's now 150. That's where it is now. That's its new value. It started at 200. That's its reference value. So 150 minus 200, that's negative 50,000. Your house is, lost $50,000 of its value, right? So that's where the negative comes from, because it's always the new value minus the reference, the starting stuff. Now, a relative change is just taking that difference and then dividing by the starting amount so we can get it relative, right? How big was that change in comparison to where it started? So back to my example, if we go from 200,000 down to 150,000, right? That gives us a negative $50,000 change. And where did it start? Started at 200,000. That looks like a zero. 200,000. And if we do the math, right, we can just divide here. That's negative 5 over 20. And if you stick that in your calculator, you get negative 0.25, which equals negative 25%, which means your house basically lost 25% of its value. And if you take 25% of 200 grand, you'll see that's 50,000, and that's the $50,000 absolute change that you had. Here's another example, right? Your stock portfolio goes from 1,500 to 2,250, so you do the absolute value, or sorry, the absolute change of 750. You do the absolute change of where it started, which was 1,500, and you get 750 divided by 1,500, which is 0.5. You turn that into percentage, and your stock or your portfolio, whatever it is, has gone up by 50%. Here's another example. Your computer started at you bought it, it was worth 1,000. Now it's worth 300. That's an absolute change of negative 700. And if you take that negative 700 and divide it by the starting amount, which was 1,000, right, then you get that it went down by 70%. That's what the second one is, right? So you take that negative 700, because that's how much money it's gone down in value, divide by where it started, and it's basically lost 70% of its value. Okay, so remember we talked about changes, absolute change and relative change. Now all of a sudden they're going to call it absolute difference and relative difference. It's really the same darn thing. It's just when we talk about change, it's usually the same thing that has changed over time, right? The price of your computer went from this to this. The price of your house went from this to this. The price of your stock portfolio went from this to this. So that's one thing that's changing. Absolute difference and relative difference is used when we have two different objects and we're comparing them. What's the absolute difference between the cost of your house and the cost of my house, right? Or the cost of your computer and the cost of my computer, or the cost of your computer and the cost of your TV, right? They don't even have to be two of the same thing. So when you use two different objects, you talk about it as being a difference. When you use one object that is changing values over time, it's called a change. But really, it's the same darn thing, right? What did we do before? When we had the change, we said, okay, it started at some number, went to another number. We took the difference between those two. Well, that's exactly what's happening here, right? You have a compared value minus a reference value. The only thing you have to worry about is which one is the compared and which one is the reference, and it really just comes down to the wording of the question. And then when you want to find the relative difference, just like the relative change, you take the absolute difference, just like we took the absolute change before, and then divide by the starting amount, right? So the reference value you can see is the starting amount, right? Before it was how much it changed divided by where it started. So here it's the difference divided by the reference value. So it's the same thing. It's still change over where it started. So that kind of helps you to understand that the reference value is what you consider as where you started. Here's an example. So average pay for full-time wage earners varies from state to state. So a recent study showed that in New York, the average rate was a little over 60 grand per person, right? South Dakota, a little less than 33. They want you to compare the average rate in South Dakota to that in New York in both absolute and relative terms. So because we're comparing South Dakota to New York, this wording tells us that we're going to use South Dakota as the compared value and New York as the reference value because we're comparing it to New York, right? That's the thing we're referencing it. So New York becomes our reference value. So now according to our formula, we do compared value minus reference value, and it says that South Dakota is $27,500 less. And then we take that number and then divide by the reference value, which is the 60 grand. And we get negative 45.6, which tells us South Dakota employees on average make 45.6% less than New York. Okay, and that's what we're talking about here in this paragraph. All right, on to of versus more than or less than, more vocabulary. Okay, so a lot of the confusion, problems, misuses, and just mistakes that are made with percentages really come down to vocabulary, because there is a big difference between of and more than or less than. When you talk about 35% of something, then you take that number and multiply it by 35% or multiply it by 0.35. When you talk about 35% more than or less than something, then you're either adding 35% to something, right, if it's 35% more than, or you're subtracting 35% if it's 35% less than. And that's where the idea of 100 plus p and 100 minus p, right? So if your computer, let's say, costs 20% more than your television, then it is going to be 100 plus 20 or 125% of the cost of your television. So just to make the math easy, let's say your TV costs $100, then 120% of that is $120, and your computer costs $120, and you have a very cheap TV and a very cheap computer. But you get the idea. Okay? So that's the idea of versus more than. Of is multiplication, more and less than, you have to add or subtract them from 100, and then take multiplication, right? Because the word of always implies multiplication. So again, here's some other examples. If Carol earns 50% more than William, then she has 100 plus 50 or 150% of his income. So if we know what his income is, we can just multiply that by 150% or 1.5 because 150% is 150 per 100, which is 150 divided by 100, which is 1.5 as a decimal. So you would take 1.5, multiply it by his income, and you would get her income. A store is having a 25% off sale. So how does an item sale price compare to its original price? Well, if you take 25% off, isn't 75% left, right? So you take 100 minus 25, and that's 75%. So that means the sale price is 75% of the original. So let's say the original price was $40. If you take 75% of that, it's now $30. Well, if you take 25% of 40, you get that 10, and if you take that $10 off, that's where the price becomes 30. Okay, so it works both ways as long as you do the math properly. Percentages of percentages is another place where people mess up, because percentages of percentages really means you're working with decimals on top of decimals, and as human beings, we tend to hate decimals and not do well with them. So they're kind of worded differently, and depending on the wording means the math is a little bit different. So if they talk about a change in percentage points, then they're talking about an absolute change. But if they use the percentage sign or the word percent, then it's a relative change. It's that whole idea of difference over, starting point. So if a bank increases its interest rate from 3% to 4%, that went up by 1 percentage point. And that's just an absolute difference of 1 percentage. And in this case, you can think of percentage as really just a unit of measure. It's like going from 3 feet to 4 feet. That's a difference of 1 foot. But instead of feet, it's percentages, right? So percentages just becomes kind of like this unit of measure thing. But if they want to know the relative change from 3 to 4, then you go the new one, which is 4, minus the starting point, which is 3, and that gives us a 1%, right? And then you take that 1%, divide it by where you started, which is 3, and you get 1/3, and 1/3 is 33, right? So 33% total. Again, you're thinking, but where are the percentages? Shouldn't it be a percentage of a percentage? No, because when we're talking about this, percentages just become like a unit of measure. So it's like 4 feet minus 3 feet is 1 foot. That 1 foot divided by the 3 feet means that it just had a 1/3 or a 1/3, which is 33%. So it was a 33% increase in feet. But in this case, it's a 33% increase in percentages, right? Okay, solving percentage problems. Again, if the compared value is p% more than the reference value, then they're just using the 100 plus p% thing. And we can solve things by using that idea. And if it's less than, then they're just using the 100 minus p. So really a lot of solving these things just comes down to kind of translating them properly and remembering that of is multiplication, right? Percent just means divide by 100. More than means that plus 100, and less than means 100 minus that thing. So you purchase a shirt with a labeled pre-tax price of $21. The local sales tax rate is 6%. What is your final cost including tax? Well, the final cost is going to be the price plus 6% of the price, right? So basically price plus tax. Now you could really honestly just do this in 2 steps. You could just say, all right, well, this is just going to be $21 is the price plus 6% of, sorry, 28 all of a sudden, of $21. And 6% of $21 is just 21 times 0.06, right? Which if you bring out your just equals $1.26. So the price is going to be 21 plus $1.26. But you can kind of save yourself a little time when you realize that that tax is just being added on to the price of the shirt. So you need all 100% of the price of the shirt plus the extra 6% for tax. So you really just need 106% of the price of the shirt. So then take 106% of 21, which is 21 times 1.06, because 106% as a decimal is 1.06. And then there you get the same 22.26 with just kind of like one fewer step. Okay, some places where there are abuses of percentages, really it just means places where you could possibly make a mistake or misunderstand or misinterpret. So the most popular one is shifting reference values. The idea that if something goes up by 10% and then goes down by 10%, that it's the same, or it gets back to where it started, or vice versa. If it goes down by 10% and then goes up by 10%, it's also going to be back to where it started. And that is never the case. The reason why is because a 10% increase, right, versus a 10% decrease, your reference value is different each time. Another place where there are mistakes is the idea of less than nothing. So you'll see this, it's just poorly worded stuff in advertising all the time where they'll talk about, hey, this thing can decrease your caloric intake by 150%. Well, you can't decrease something by 150% because you're taking away 150% of that thing, right? You can't decrease it by 150% because now you're in negative 50%. Because if you decrease it by 100%, you're taking all of it away, and then you decrease it by another 50%. How is that possible? What they probably meant is that it's like 150% less. Even that doesn't work. I don't know how they would. They've got it all messed up. Don't average percentages. This is a big one. It's kind of the same thing as averaging averages. So if 70% of the boys and 60% of the girls in a class voted to go on a water park, then 65%, the average of 70 and 60 of the students in the class voted to go on the water park. That is hugely false. The only time that would be true is if the boys and girls were the same amount, right? You had exactly the same amount of boys and girls, so like you had 20 boys and 20 girls. Then it would work. But if these two groups have different sizes, then 70% and 60% of them are going to be different amounts. And then you won't get an average of those two percentages when you talk about the group as a whole. And we'll do some examples to illustrate how that is not the case. So here's the first abuse of the changing, the shifting thing. So the stockbroker says, well, sure, your investments fell by 60% during my first year on the job. However, their value increased by 75% the next time, so you're 15% ahead, and that's totally wrong. And the easiest way to check it is to use some numbers. So imagine you began with an investment of $1,000, right? During the first year, you lost 60% or $600, leaving you with only $400. Now, during the second year, he tells you that it gained 75%, but it's 75% of that 400, not 75% of the original 1,000. So you do 75% of 400, which is only $300. And so now at the end of the second year, your investment went from 400 up to 700, right? 4 plus 3. Which is still $300 less than where it started, so you didn't have a 15% gain overall. You actually still had a 30% loss. A real common other one is, it's kind of one of those old parable things where they say, hey, you know, the company is not doing well, so if you agree to a 10% pay cut this year, we'll just give you a 10% raise next year and get you back up to where you started. And that's never the case, right? Because think about it this way. If you started with a salary of $100, your 10% cut, right, gets you down to $90. And then the next year, you're supposed to do a 10% increase, but that means you're increasing your $90 salary by 10%, and 10% of 90 is 9, and that gets you back up to $99, and they just screwed you out of $1, right, or 1%. Okay, in baseball, here's another example of the idea of averaging averages or averaging percentages. So in baseball, when they talk about a batting average, a .35 or what they call a 350 batting average just means that they get a hit 35% of the times that they're at bat. Now in this scenario, a player had a batting average of 200 or basically 20% in the first half of the season, and a batting average of 400, which by the way is really good, or basically hitting 40% of their balls in the second half of the season. So if they had 20% in the first half and 40% in the second half, can we conclude that their batting average for the entire season was 300 or 30%? And can we average that 20 and 40? Why or why not? Well, the only way we could average those two numbers is if they had the same number of at-bats in the first half and the second half. It's not even the same number of games, because it's all about at-bats in this case, right? Your batting average is based on how many times you're at-bat. So if they had, let's say 35 at-bats and they got a hit 20% of the time, and then they had another 35 at-bats and they got a hit 40% of the time for those, then yes, their average would be 30%, but that's only because the two sets were the same amount. If they're two different amounts, it doesn't work. And if we just do it with some simple numbers, let's say in the first half of the season, they had 100 at-bats, and in the second part of the season, they had 200 at-bats. So if they were batting 200, then that means 20% in the first half of the season, they got 20 hits. If in the second half of the season, right, they were batting 400, that means they got 40% of their at-bats was a hit, so 40% of 200 gives you 80, right? Hits. So if we want to know their average for the entire season, we have to do total hits, which in this case is 100, divided by total at-bats, which was 300, right? So 20 plus 80, 100 hits over 100 plus 200, 300 total at-bats, which is 1/3, which is .333, which means they're now batting 333, not 300. Okay, so those are some of the uses and abuses of percentages.